what is the necessary or what is the need of this symmetry in FEA, we will understand first. So before that, I will give a small demo of example. So here is a watermelon. So let's cut it. And you can see it is converted into two halves, which is identical and equal to each other. So this is the one example. So based on this example, we will move ahead. So types of symmetry and why it is needed. So basically in the FEA, we have two nodes and elements which are most important part in our FEA. So let's put it on the graph. So when the number of nodes in your problem or in your project will increase or number of elements will increase, it will increase the solving time. So as nodes increases, solving time will be more. But the accuracy is very good when there is a number of nodes are very high. So let's move to the next graph. So there is a picture of computational power, that is computational efforts we can say. So which is consist of RAM, graphics card and memory which is heavy. So if we have low RAM or low computational power, then time required for solving this problem is more. So if we have good RAM, good memory and good configuration, so time required for solving this problem is very less. So ultimately, after this FEA problem, number of nodes, number of elements, computational power, we have to consider about the time. So we want to get the solution done in less time with higher accuracy. So how to achieve in some problem? So there comes the types of symmetry in the picture. So let's understand what is symmetry in FEA. So basically there are four types of this symmetry. One is axial, planar, cyclic and repetitive. So first one is axial. So axial symmetry is, suppose there is one object which is symmetrical about one axis. So here is one conical shape of cylinder and it is symmetric about this axis. So when I cut the section over here, so it will look like this. So suppose in this problem we are applying some pressure over here and we have fixed over here. So same boundary conditions can be applied on this. This is the pressure and this is the fixed support. So we will get some result for this problem, this cross section. So ultimately if we want to model this, we will get higher nodes, higher elements. But in this problem, which is the cross section or 2D, so we will get less nodes. We can refine this so that it will be having more nodes, but which is less than this model. And we will get good results for this cross section. Now in software we can rotate these results about its axis. So we will rotate by whatever the angle we need. So we can rotate it by 360 degree. So when we rotate this 360 degree, only result we are rotating, not the model. So we will get the result of whole this 3D part. Even we can do it for 180 degree, 90 degree or whatever the degrees you need. So this is called as a axial symmetry. So condition is that it should be symmetric about the axis. So moving forward to the next. Planar symmetry. So in the planar symmetry, you can understand about the mirror. So object is mirror about the one plane. So here is one plane. On this plane, it is symmetric about this. Even on this plane, it is symmetric about this. So it is about X plane or its Y plane, which is symmetric about. So we can consider the mirror part. So in this geometry, if we consider, so this is the half portion which is symmetric about here. So we can consider half portion. even this portion is symmetric about one plane. So we can consider only this. So in this case, suppose we are applying some pulling force over here and pulling force over here. So that can be converted into this. So some pulling force will be applied here and some boundary conditions which will be applied here and some boundary conditions will be applied over here. According to that, we will solve this problem. And which result we will get, that result will be reflected upon this plane as well about this plane. So on these two planes, we will reflect to each other. So we will get the full ultimate result. So solving this problem requires less time. Even we can refine this model with greater number of nodes and solve it, and so that we will get the full result for this your planar geometry. So moving to the next type of symmetry, that is cyclic symmetry. So in cyclic symmetry, so what is the difference between axial symmetry and cyclic symmetry? So don't get confused here. So in axial, we will be having one cross section. So in this case, if you take a cross section over here, so that is a different cross section. But if you get cross section here, that is a different cross section. So that's why axial symmetry is not applying over here. But if you see, there is a part of this component. Now this is the part of this component. If we take it all the way about this axis, so you can see similar components are attached together. So that's called as a cyclic symmetry. So you can take this part out by cutting this over here and analyze this part and just rotate it by number of components. So we will get the final result. So this is called as a cyclic symmetry. So here we have to consider part of the component in the cyclic analysis. Last one is the repetitive. So in the repetitive analysis, so the component is like this and it is repetitive about one direction. It's not axis or it's not a plane. In any direction, it is a repetitive. Just like a railway train, it is a repetitive bogies. So we have to consider the again part of the component and the direction which it is. So here, this is the component which is symmetric about this direction. So we will consider only one component like here and we will analyze that and we will make the result symmetric about this axis. So we will get the results on each component. So finally we will get the result of full model. So what are the benefits of this symmetry? First one, it saves time because the model which is actual model and we are analyzing model is very less, very small as compared to full model. So it will save the time, no doubt. Now low computational efforts means what? So if this node count is 1 lakh and here node count is 10,000. So solving this problem requires less amount of computational effort. So it will solve and the results which we will get is kind of similar on the both full model as well as this symmetrical model.